Okay, as promised, I'm going to do some extra notes for limits at infinity because I misspoke in the video. You'll notice we're no longer at the whiteboard. However, I am at home and I don't have a full-size wall whiteboard here. So I made my makeshift hover cam. It's not exactly perfect and my hand will be in the way and I will pull back when necessary. All right, so our first problem here says the limit as x approaches infinity of x squared minus 1 over x squared plus 1. Now, in the video, I said divide by the highest power of x. It was supposed to be said divide by the highest power of x in the denominator. So we want to make sure that we are dividing by the highest power of x in the denominator. So in this problem, it wouldn't matter, but in the next coming up, it will. So in this problem, our highest power in the denominator is x squared. So we're going to go ahead and take the numerator, x squared over x squared minus x squared, 1 over x squared over x squared over x squared plus 1 over x squared. Okay? Now, anytime you divide, you want to cancel where appropriate, and anytime you divide a number by any power of x, it becomes 0. So here, those cancel down to 1. Those will reduce to 0. So you get 1 minus 0 over 1 plus 0, which is 1 over 1, which is 1. So the answer to that is 1. And if you remember the rules of horizontal asymptotes, that would be 1 that way as well. Now, here is one that is a square root. And again, highest power in the denominator is just x. But remember the rule with square roots, you want to make sure if you take the square root of that, it pops out. So usually it's the number in the square root, the letter in the square root. And I haven't seen any where they've given you any other types of problems where the square root is smaller on the final. So I'm not going to do that, nor will I assign them. All right, so in this case, you want to divide everything by x outside and everything by x squared in the numerator. So here it's going to be 2x squared over x squared plus 1 over x squared over 3x over x minus 5 over x. Okay, so when we do this problem, again, we're dividing by the highest power in the denominator, but in this case, we're going to make it x squared, okay? Don't mind my dog. He's barking if you can hear that. Sorry about that. All right, so here we're going to get 2, okay, plus 0 over, that cancels. So you're going to get 3 minus, that becomes 0. So then your answer is square root of 3 over square root of 2, sorry. Square root of 3 over square root of 2 over 3. Sorry about that. So square root of 2 over 3. All right. Now we're going to end up with one that doesn't have a denominator, which we didn't go over in the video, so I'm going to go over that now. Well, if it doesn't have a denominator, you can just simply plug in infinity. So we would get infinity squared minus infinity, and that would be just infinity minus infinity. When you square infinity, you can't get any bigger than infinity. And when you subtract, you don't get 0 here. That's one mistake people make. You actually get infinity, okay? You actually get infinity. So in that case, you got to be careful. So usually if it's just a polynomial, it will always be infinity. And if you think about this is a parabola that opens up. So there it is, okay? So we have a parabola that opens up. The limit as x goes to infinity is going to keep going on forever. And as x approaches infinity, it's going to keep negative infinity, it would go on forever. So again, that's where it's the case. There are no asymptotes, horizontal asymptotes. Okay, so that brings us to our last problem. Now this one is probably the most difficult because here's a situation where the denominator has x, the numerator has x squared. So we're going to divide everything by the highest power of x in the denominator. So in this case, we're going to divide everything by x, and you're going to see what happens here. So you're going to get x squared over x plus x over x, 3 over x minus x over x. Okay? So again, we have a situation where you're just going to divide, but what's going to happen, we're unique, is we're going to be unique right here, okay? So what's going to happen is this will cancel. You can be left with x over 1, okay, plus That cancels to 1. And then that's 0. 3 minus x turns to 0. Minus, this turns to 1. So now we end up with x plus 1 over negative 1. Okay? So what does that mean? Well, again, x is going to infinity. So you're going to get, that's a polynomial in that numerator, see, x plus 1 right there. So what I just say in the previous example, that if it's a polynomial, it goes to infinity. So that's going to go to infinity. But you're dividing by negative 1. Therefore, this one will be infinity divided by negative 1, which is negative infinity. So that can't happen. You can get negative infinity as an answer, okay? So hopefully those examples helped you with the homework problems. If not, please email me your questions.